feature that allows you to specify per cluster identity access management credentials. So a very common concern, especially for enterprise customers, is how do I secure my data? And that's a very important concern. So with Cloud Data Proc, you can create clusters and scope them with very specific user credentials. You can specify users or groups that can do things on that cluster and specifically tied to that cluster. I want to quickly talk about some of the best practices with Cloud Data Proc. First, if you start using Cloud Data Proc, we really try to help people split their clusters and jobs. So if you have jobs that you want done very quickly, you can create a very large cluster scope to run your clusters very quickly. If you have long-running jobs and you don't want to spend a lot, you can create clusters that are specifically sized and scoped for just that. Splitting your clusters and jobs will ultimately allow you to potentially realize cost savings over time and also ensure that your clusters meet whatever SLAs or other requirements you have. So if I wanted to create a development cluster just to test out new versions of Spark and Hadoop, I can do that. And when I'm done with my tests, I can just delete my cluster. I don't need to worry about copying data, moving things around. Instead, I can use the mechanisms of Cloud Data Proc to create clusters that are specifically scoped for the tasks that I want to perform. You should also create and delete your clusters often. If you have work to do, you can create a cluster, run your jobs, and delete your cluster. There's really no reason to run your cluster persistently. Especially since you can generally get clusters in under 90 seconds, you really only need to create clusters when you actually have work that you want to perform, and you don't need to leave them running when you don't have work to perform. You should also use cloud storage. So as I mentioned, cloud storage is a replacement in Cloud Data Proc for HDFS. When you create a cluster, we run HDFS, but it's typically only for temporary operations. So shuffling, spilling, things like that. Aside from that, cloud storage offers you typically better speed and economics versus running HDFS on a cluster. Plus, it also means that when you create and delete clusters, your data is not specifically tied to that cluster. Ideally, if you're scripting against Cloud Data Proc or just submitting work to it, the Jobs API will make life easier for you. So instead of using things like SSH or things like Hue, you can instead either use our client tooling or our Jobs API to submit and run work on your cluster. I'll show this in the demo in just a minute. You can also use tags with your cluster. So tags are key value pairs that you can use and associate to your cluster. These allow you to do things like cost accounting. You can get and list clusters by the tags. So maybe I have a fleet of production clusters. If I wanted to add more capacity to my production cluster setup, I simply only need to create a cluster and add a tag that identifies it as a production cluster. If I wanted to remove that cluster for deletion or maintenance or whatnot, you can just remove that tag. Alternatively, if you wanted to see how much your accounting group, for instance, uses your Spark and Hadoop cluster, you can submit jobs with that tag to get very specific accounting tied to that group. In terms of data migration, you really should use cloud storage instead of persistent disk. It will give you much better economics, it will give you much better speed, and it also makes sure that your cluster is not specifically tied to your data locality. So if you delete your cluster, we obviously don't want you to lose any data. You should really think about how you segment your data when you move to cloud storage, because you could potentially use the various tiers of cloud storage to save time and money. In terms of cloud storage versus persistent disk, cloud storage will usually give you better throughput. In some rare cases, things like append don't really work all that well, or if you have very small files, you may notice that latency is going to be higher than HDFS. These are not common use cases, but it's a good thing to keep track of and think about when you plan your data migration to cloud storage. So I want to quickly show you how easy it is to create and delete clusters with Cloud Data Proc. You can see that I filled out a few default options here just to save time. In the web UI, there's the option to both create clusters and jobs, and this is the cluster creation form. I specified a few default options. In this case, I've done things like specify a name, a zone, and the configuration of my cluster. We're going to create a modestly sized cluster here. It has 100 workers with 16 cores. We'll have 1,600 total yarn cores. I'm also going to run an initialization action to install Presto on my cluster. You can also see at the very bottom, if I wanted to do this via REST, there's a very easy way to do that with our REST API. There's also a really easy way to do it via our command line. So if I wanted to use the Google Cloud SDK to create this cluster, it's very easy to do. In this case, I'm just going to go ahead and use the web UI to keep things simple. So once I create the cluster or click the Create button, the cluster is going to provision itself behind the scenes. I'll come back to this cluster in just a moment. I've also filled out a form to submit a job to the cluster. So in this case, I've specified the cluster where I want to run this work, which is the cluster I just created. We support a number of job types. These are workloads that you can run on a cluster. So you can see that we support things like Hadoop or Spark or PySpark. In this case, I'm running Pig because I'm actually using Pig to shell out and then go call Presto. It's a somewhat convoluted use case, but I do want to show that you can really use a cluster any way you want. Just because you're using things through Cloud Data Proc, we try not to restrict you or box you in. You can see the SQL file that I'm running against this cluster, and I've also added an optional label to this cluster. So in this case, I'm adding a label where a group is equal to demo. So later on, if I wanted to see all of the jobs where the group was equal to demo, I could easily do that. Again, it allows me to do things like cost accounting or resource usage. If we quickly go back to our cluster and open up the cluster details, you can see that Cloud Data Proc provides you a really high-level overview of the cluster. So in this case, we can do things like look at CPU utilization, we can look at network I/O. This allows you to just get an orbital level view of what is running on the cluster or how your cluster is functioning. In addition to this view, you can also use things like Stackdriver to get detailed log and resource usage of your cluster. Behind the scenes, if you're paying attention, you can also see that this turning wheel turned to a check mark. So the cluster is ready to use. So in just the time that I've been talking, the 1600 core cluster is ready to go. You can see what work has been submitted to the cluster, which is nothing right now. You can also look at the virtual machines that are attached to this cluster. So you can see that there's a whole lot of compute engine instances that are part of this cluster. And we can do things like resize this cluster. So just to show you how flexible Cloud Data Proc is, let's go ahead and resize this cluster before I submit some work. The reason for showing you that is to really underscore the fact that if I modify this cluster, I don't have to stop submitting work to this cluster. I don't have to worry about my cluster being unavailable. Cloud Data Proc is designed to handle all of these things behind the scenes. So my cluster is in the process of resizing itself. Let's go ahead and submit that work to the cluster. Once I click this Submit button, you can see that the job is going to start processing on the cluster. In addition, if we go back to that cluster view, we'll be able to see that that job is now associated with this cluster. Moreover, we do things like capture output from the cluster. So I don't need to do things like open up SSH terminals or worry about losing logging output. The Cloud Data Proc Jobs API is really designed to make it as easy to use without giving you less information or abstracting things away too much. Once this cluster is done processing this job, we can also just simply delete this cluster. So in this case, let's go ahead and just say that we were done with the cluster. When I'm done with it, I can just simply click this delete button and the cluster would go away. So again, when I have work to do, I can create a cluster and run the work, and then when I'm done, I just click the delete button and don't have to worry about the cluster sticking around. So there's a few key takeaways that I want to talk about in terms of Cloud Data Proc. First, we've really tried to make Cloud Data Proc as fast as possible. Again, you could see that we were able to create a modestly sized cluster pretty quickly. We were able to submit work to that cluster pretty quickly. We want you to be able to move as quickly as possible with Spark and Hadoop without worrying about the infrastructure or management of clusters. Second, we want Cloud Data Proc to be easy. Again, you saw me submit a bunch of SQL to the cluster without having to open a terminal window or log into additional applications. If you have work to do, we want you to be able to submit work to the cluster as easily as possible. And third, cost effectiveness. So when I create that cluster, I'm billed with a 1-minute minimum increment, and I'm billed by the second thereafter. So if I use, for example, 800 seconds of a Cloud Data Proc cluster, I will be billed for 800 seconds of a Cloud Data Proc cluster. We don't want you to have to pay for more resources than you need just to use Spark and Hadoop. I'm James Malone. Thank you very much for joining this session, and please stay tuned for other Cloud OnAir sessions.
Of course, and that kind of computation power that Google can provide, that's really something I would not be able to do in my own laptop. That's true.
Great. So let's welcome back the big data track. So they were just talking about using open source technologies like Spark and Hadoop inside of Google Cloud Data Proc. The next The next session there is around the Internet of Things. So definitely a big data topic, and then one that is getting a lot of attention at the moment. So enjoy your session.
Welcome back to Cloud OnAir, the journey from big data to AI. A big welcome to all of you joining us around the world. My name is Jen Bennett, the director in the Office of the CTO, along with my colleague Indranil Chakrabarti, who leads our product management for Cloud IoT. As a reminder, please submit your questions. Google experts are on standby to answer them. So you may have joined today because, like me, you believe in the future of a connected world and have a number of aspirations around what's possible. Or perhaps you've joined because you've heard a lot about IoT and want to learn more. New possibilities are emerging every day due to advances in technology, but married with imagination around what's possible. When the connected world meets machines that are learning, we realize opportunities of the intelligent Internet of Things. What does that connected world look like? Well, imagine for a moment how much valuable time you've spent hunting for parking, circling the block, getting more and more frustrated. What if parking was available when you needed it, where you needed it? Or perhaps like me, you travel quite a bit and have been delayed or stuck one too many times. Imagine no longer having schedules delayed or disrupted due to maintenance issues. Or perhaps you're passionate about energy and how we utilize energy in an optimal way, every day, everywhere. Maybe even closer to home, personalized medicine, made and tailored just for you. These aspirational goals are not that far away. With 8.4 billion connected things and counting, a number of possibilities are becoming reality every day. If we look at what happened when we connected billions of devices, we delivered new insights, new experiences. And this has led to new ideas, including AI-first experience. Along the way, we've learned quite a bit about connecting billions of things. The amount of data has exploded and will continue to grow, so petabytes, exabytes of data. You must master data. And Google's history in big data dates back to 2005. Everything from storage solutions like Bigtable, to MapReduce for data processing, to interactive analysis at scale with BigQuery. These technologies have become industry standards in the open source community and enjoyed the innovation of the broader ecosystem. And that same technology that powers such large applications as search and maps and ads is now powering numerous applications throughout the industry. Taking data and applying large-scale compute, we add intelligence through machine learning. Machine learning is not just for games. Whether we're talking about products like Google Home or Nest or Pixel, even Google data centers, we have taken connected to a new level by applying intelligence. In many ways, driving double-digit improvement in performance. But this transformation, enabling these aspirational goals to become reality, sits at the intersection of connected things, big data, and machine learning. So connected things that are learning. What's important to remember, though, is it starts with connecting things and taking that large-scale data and gaining better insight, delivering new experiences, leveraging machine learning to supercharge your ability to make those devices intelligent. So without further ado, I'm going to introduce my colleague Indranil, who will talk to us a little more detail about IoT.
Thanks, Jen. So Jen talked about the intersection of connected things, big data, and machine learning. And I'm Indranil, and I want to go a little deeper into the product offerings we have to get you jumpstart into your journey for intelligent Internet of Things. So let's get started. Before we get into the product offering, I want to give you guys a quick demo. So I'm going to switch tabs here. So let's take the example of oil and gas. If you think about an oil and gas company, there could be hundreds or maybe thousands of rigs across the globe. And what some of these companies would want to do is to real-time monitor the status of each of these rigs and want to figure out if any of their components or their drivers need some maintenance. Because any downtime in these rigs, any minute of downtime can cost them thousands or even in some cases millions of dollars. So here we've built a demo where we have simulated data from simulated oil rig data. And as you know, each oil rig has a number of components, right? So there are crown block at the top, and sometimes there are traveling block, and there are other components. Each of these components have multiple sensors. And so what we're showing here is using our Google Cloud platform and simulating data from oil rigs, you can monitor real time for each of these components the different sensor data, value from the sensor data. So for example, here the component is the crown block on one of the rig, and we can monitor the cable tension, the differential pressure, the oil temperature, and even the viscosity. And this all is being monitored real time. So and if I go down a bit more, you can also look at the time series data from all these different sensors for each of these drives. So it's a pretty valuable set of data which you can use for real-time monitoring. Not only that, what you can also do is once you've collected enough data, you can now start building, using machine learning, you can start building models to predict the number of life cycles left for any particular component. Just now, as you see, we're tracking real time. You can predict the number of life cycles left for each component. And as you see, when you see that any component has gotten into a critical state where it requires maintenance, you can either schedule maintenance, like the way I can do it here, or you can set some rules to automatically schedule maintenance for you so that you never have, as an oil and gas operator, you never face any downtime. So this is a quick screenshot and demo of how you can use Google Cloud Platform and the intersection of connected things with big data and machine learning to not just real-time monitor your operations of the oil and gas rig, but also be able to predict downtime and do maintenance so that you can avoid any downtime altogether. So here's how the architecture for this particular demo looks like. So we have oil and rig, as you can see, the rig on the left side. It's pulling oil, and we have simulated data from oil and rig, and all this data gets sent to Cloud IoT Core, which I'm going to go a little bit more deeper into in a minute. That data gets published to Cloud PubSub, and from PubSub you can consume the data using Cloud Data Flow for real-time event processing, and you can build some complex business logic as well. Then from the Cloud Data Flow, the data gets stored into BigQuery, which, as you know, is one of our premier data warehousing and analytics tool, which you can use to not just store data, a massive amount of data in a cost-effective way, but you can also use it for doing deep dive analytics. Furthermore, we have Cloud ML, which you can use to run TensorFlow model, and you can use the data from which you have stored on Cloud BigQuery to train a model and then predict, in our case, the remaining life cycle for any component. So what we have here is we've taken an example of use case of predictive maintenance, applied it to oil and gas, and we're showing you how you can build an end-to-end solution using Google Cloud Platform and the different services we offer here. So I'm going to go back to our presentation and walk you through some of the components which we use and which we think you can use as you jumpstart your journey on intelligent Internet of Things. As you know, Google has over 2 billion monthly active Android devices that are connecting to our cloud infrastructure on a daily basis. And they transact a massive amount of data. We have more than 1 billion YouTube users connecting to our cloud infrastructure every day. So over time, we have built an infrastructure which can really scale to not only connect this massive amount of devices, but also be able to easily ingest a massive amount of data, store it cost effectively, and then you use our other services for analytics and machine learning. We've announced a product called Cloud IoT Core, which is built on the same infrastructure that is being used by Android devices and other Google consumer products to really make it easy and simple for customers and partners and developers like you to build IoT application on Google Cloud Platform. So what is Google Cloud? What is Cloud IoT Core? So let me get a little deeper into Cloud IoT Core. Cloud IoT Core essentially it's a fully managed service to securely connect and manage your global IoT device network. What it means is it allows you to simply connect, make it really easy and simple to connect your IoT devices at scale in a secure way to Google Cloud so that you can start benefiting from the downstream services for Google data analytics and machine learning services. Cloud IoT Core has 2 key components. We have a protocol bridge, which allows you to connect your existing devices using industry standard protocol such as MQTT and HTTP. And the great thing about this protocol bridge is it's fully managed. So you don't have to worry about instantiating a VM or sharding your services as you scale. Whether you connect few devices or hundreds of thousands or even millions or billions of devices, we scale internally. You just connect your devices and you focus on building an application. We take care of scaling internally. So it has automatic load balancing, and Cloud IoT Core is tightly integrated with Cloud PubSub, which is our managed service for data routing and data ingestion. So it's great. It can give you a global access view and allow you to centrally manage and monitor all your globally dispersed devices. So that's for the protocol for connecting your devices. So we have a protocol bridge for connecting your devices. We also offer some key device management functionality. So we care about security deeply. So with Cloud IoT Core, you can individually configure your devices, and we support asymmetric key-based authentication to make sure that each device is individually authenticated for connecting to Google Cloud. You can also update and control your devices. So we have the provision for you to send configuration updates or firmware updates and even some commands over to your devices via Cloud IoT Core. And the great thing about our Cloud IoT Core is when your application tries to send an update or configure a device, we take care of propagating that new configuration to the physical device when the device is connected. So you don't have to worry about whether the device is connected or not. You just use it, your application just connects, calls the APIs, and we take care internally of connecting the devices. We also have role-level access control. So we support IAM at Cloud IoT Core, which allows you to, at a very granular level, provide access control to a group of devices to a certain user. And finally, we have a rich set of APIs so that you can really build application on top of Google IoT Core. Another thing about Google Cloud IoT Core is it works seamlessly with other cloud services such as PubSub, Dataflow, and BigQuery and CloudML. So as showed before in the oil and gas demo, you can, once you have onboarded your devices and when you start ingesting data from your devices via Cloud IoT Core, you can use our downstream services such as BigQuery and ML to build either real-time monitoring system or even use CloudML for doing predictive maintenance and building predictive models as well. So with that, let me give you a quick demo of how the product looks, how you can use the product to get started. So we understand that as you're starting on your journey, many of you want to build some quick prototype, want to build some quick proof of concept to get started. So we have a simple UI on Google Cloud Console to get you started. So if you go to Google Cloud Console and scroll down, you would see a line item called on the menu called IoT Core. You click on that, and it takes you to a collection of registry. Now, we have this notion of registry, which essentially is a collection of devices. So you can define one or multiple registry, and with each registry, you assign a particular region where you would want your device metadata and your device data to be stored. And also you can define the protocol and the POP subtopic, which I'll come to. So if I click on a registry, for example, we have created a registry here. So what you see here is it shows you the region, it shows you the protocol you support, it shows you the POP subtopic where the data will ultimately get published to, and shows you a list of all the devices which are registered on this registry. What it means is that each of this device, the data from each of this device will get published to the POP subtopic here, which you can then use to consume and send it to your downstream services. If you click on a particular device, for example, let's click here, it shows you some quick stats in terms of the last message that was published by the device. It also shows you the key, authentication key, which we're using for authentication, for the device authentication, and so on and so forth. You can also click here, and you can see some more data around the configuration and the state history of the device. So let's get into let's start creating a registry, and I'll really walk through that process of how you can quickly create a registry, add a device, and get started. So I'm going to go back to the registry details, and I'll say I want to create a registry. And I can say, let's say demo, today's let's say 17th of 2017. So I give an ID for the registry. I select a cloud region. We have 3 regions currently supported. So you can select either Central, US Central, or Europe West, or Asia, depending on the region where you want to store your data. By default, each registry supports both protocols, MQTT and HTTP. And you have to select a POP subtopic where all the data will get published to. So let's say I'm going to select this topic. We have also added a provision for you to select a topic to receive state updates from the device, which I'll come to in a bit. And once you've selected a POP subtopic, if you want to, you can also add your own CS certificate at the registry. And what it allows you to do is it allows you to verify that the devices when they connect with their with their public key, it verifies the ownership of the device. So if you have a CA which you work with and you want to sign all the keys or the private keys for all the devices by the CA, you could do that. In this case, for now, I'm just going to leave it as none, and I just create. Now, what this has done is it is allowing you. We want to make sure that we want to give access to the POP subtopic so that Cloud IoT Core can publish data from these devices. We say continue, and boom. So the registry has been created. Now you can start adding devices. So I can just say, for the simplicity, so let's say device 1. I'm going to call my device 1. And I'm going to say I want to do ES256. And let's see, I'm going to copy the public key. And so the way it works is when you're adding a device, when you're registering a device to Cloud IoT, we expect that you will have a private key which is being stored with the device somewhere securely, ideally using a TPM. And there are open source modules for you to generate the public key from the private key, and you would take the value of the public key and add it to this console as you're registering the device. You can also add server-side device metadata. So, for example, I can say manufacturer, in this case is Google, just for the sake of simplicity. You can add firmware version as 10.1.1. You can add multiple, you can add up to 500 such server-side metadata, which you can further use downstream for searching or even for organizing your devices if you have a large number of devices. And you say add. And once you've added, that's it, you're all set. If you have a real physical device or even a virtual device which you want to test for, you can start connecting that device with the device ID, my/device/1. You can start connecting to Cloud IoT Core at either using the MQTT endpoint, which is mqtt.googleapis.com, or the HTTP endpoint. And once you start connecting it, you would start seeing data and in terms of when was the last data published by the device, and so on and so forth. So you can start monitoring it, and you can even start sending commands. So a quick example I want to show you is I talked about receiving data, but here is a simple example where if I want to, I can just send a simple instruction or a command back to the device saying, fan on true. That's it. So what it does is this means that you have an API where you've sent, using the UI, you could send a configuration update or a command to the device. And when the device gets connected, Cloud IoT Core will automatically send that new configuration to the device. And once it gets an ACK back, it will report it here. So it's really simple to get started. And if you have a physical device, you can start right away. So that was a quick overview of using Cloud IoT Core from the console. There are a lot of, if you go to Google cloud.google.com/IoT, we have documentation, we have sample code for you to connect your device using MQTT or HTTP, and there are a bunch of sample codes which you can use to get started. But I wanted to give you guys a quick overview of how the console looks like, how easy it is to really get started and jumpstart your journey on intelligent Internet of Things. So going back to the presentation. So I give you an example of how you can build a predictive maintenance demo using Google Cloud IoT Core and other Cloud IoT cloud services such as PubSub, BigQuery, and others. We have an example here. There's a company called, and as Jen mentioned about, gave the aspiration of never to have worry about parking. We actually have a company, a customer of ours called Smart Parking Technology. They're based in New Zealand, and they're using Google Cloud Platform to connect all these devices which are installed at every different parking lots in parking garages and even on the curbside, on lampposts and others, to not only give real-time view to the drivers in terms of what particular parking lot is open and available, but they're also using all the data they collect from their sensors to provide a more intelligent demand forecast to the city of Auckland through their application that they've built using Google Cloud IoT Core and other data analytics and machine learning services on Google Cloud Platform. So we're pretty excited about the potential we see here and how customers and our partners are building interesting solution using our platform. So I talked about Google Cloud and what you can do on the cloud side. I want to briefly touch upon Android Things, which is our operating system for Internet of Things. So the great thing about Android Things is it's built on Android. And what we've done is we've taken the stock Android, so you get the core benefits of Android, which is it's got a secure boot, it's got a pretty large, strong developer ecosystem. So any app you build on using Android Studio for Android, that can be easily ported into Android Things as well. And the great thing about Android Things is it also can run TensorFlow. So if you have a model which you have trained on Google Cloud, you can run that TensorFlow trained model on Android Things device and get some insights and get some local insights. So Android Things is a great OS if you're looking for a fully managed operating system so that you don't have to worry about the firmware version, the security patches. Google takes care of all of it. And if you're really interested in figuring out a way by which you can do some edge compute, Android Things is a great option to have, and I would encourage you guys to look into that as well. And we have a large number of partners who are working with us to certify their SOMs. So we have Intel, Qualcomm, NXP, Raspberry Pi, and a number of them which are already listed on Android Things website. Another thing about Android Things is if you're running Android Things on your device or on your edge gateway, Android Things works seamlessly with Google Cloud IoT Core. So here's an example where what we've done is you have a camera where we have trained the TensorFlow model to identify faces on cloud, and we constantly update the TensorFlow model as new employees join a company. And the Android Things camera can detect real time on the camera itself whether an incoming person is an employee or is a guest or is a stranger. So just an example of how you can use some edge processing and together with cloud to really offer an end-to-end compelling application. So finally, what's next? I mean, I'm sure you guys are thinking about, great, we have services on Google Cloud including Cloud IoT Core and big data services and machine learning services. So how do we get started? So there are really three things which we would really encourage you all to start looking into as you want to jumpstart your journey. One is go to cloud.google.com/IoT to get started with our product, Cloud IoT Core product. Second is, as you think about your solution, I'm sure you're thinking about the hardware which you want to use to collect the data. So we already have a pretty robust set of hardware partners who have worked with us and have made sure that their hardware works seamlessly with Google Cloud IoT Core. So you can choose a hardware kit. You can buy it from our site. If you go to cloud.google.com/solutions/IoT/kits, this link is also available from the product side, and that will allow you to give you a number of options for you to choose a particular hardware device to get started. And finally, if you want to build a quick prototype, go to our quick start document, which is cloud.google.com/IoT/docs/quickstart. And we have a step-by-step instruction with sample code for you to get started in building your application. So finally, thank you, and we're very excited with what you can build with Google Cloud IoT Core and Google Cloud Platform as you get on your journey for intelligent Internet of Things. Thank you, and stay on if you're interested in listening to some more sessions on big data and AI platform. Thanks.
And use their data for AI.
That's going to be interesting. And now joining us are the Big Data Solutions track. We just wrapped up the IoT track where we discussed on how we are analyzing our global device for real-time insights of data. So what did you think about it, Jay?
Yeah, I mean, I think IoT, I don't think there's any example of the high velocity of data that's hitting the internet than IoT devices. So I think they said 8.2 billion devices out there already, and it's only growing. So the ability of all these devices to collect data and I guess the inability for a lot of organizations to process all of that data on their own, especially in real time. So using something like Google Cloud will allow them to process that data and store it and then actually use that for AI.
And that's interesting. And the next session that we have coming up is our Zen guide to data prep for analytics and machine learning and all the best practices that come along with it.
Fantastic.
So, interesting. Now joining us is our audience from AI track, where they've just finished up on how we can simplify machine learning lifecycle on the whole in terms of exploring data and explaining predictions and, of course, deploying models. So I know, Jay, this is one of your favorite tracks.
This was such a great track because it actually tied a lot of what we're talking about throughout this entire day, right? So essentially took BigQuery, talked a lot about TensorFlow and creating models, talked a lot about exploring that data, and actually talked about deploying that data all within a life cycle. So very cool. Also coming up is on that AI track. We're going to talk about GPUs and cloud TPUs, which are tensor processing units. So you'll find out more in that session. Enjoy.
Hello, I'm Eric Anderson, and this is the Zen Guide to Getting Your Data Ready for Machine Learning and Analytics. Part of Cloud OnAir, the journey from big data to AI. And I'm glad to be here with you. Good morning, good afternoon, good evening, wherever you are. I'll be sharing with you 12 Zen principles. And along the way, you'll find that the biggest difference we're highlighting here between traditional statistics and machine learning is how you deal with outliers. What you're looking at is a zonkey, a cross between a zebra and a donkey, just to drive home the point that there are outliers, and we'd love for our predictive models to know what to do when they see them. And in order for that to happen, we need to understand and collect those outliers and have them in our sample data sets. Along the way, I'll be introducing how you can do this using Google Cloud Platform tools, including Google Cloud Data Prep. What you see here is one of the public BigQuery data sets. This is worldwide flight data shown in Google Cloud Data Prep. I've scrolled to the right where you can see departure delay and arrival delay. Data Prep provides a helpful set of histograms per column. It also gives you quality metrics and infers type on those columns. So in some cases you can see mismatched values. But our arrival delay and departure delay show an expected amount of clustering, probably around the expected arrival time. What you're looking at is a sample of the data. Data Prep relies on samples in order to have a quick user experience. Let me start by showing you the random sample. Here you can see that outliers aren't as evident. But if I switch to what we call a stratified sample, this sampling is designed to capture all the outliers you would want to see in your data set. You can see the arrival delay is actually much broader than we saw in the random sampling. Using Data Prep, you can control the samples available to you. By default, we generate a first rows or random sample, but there are other options. You can see filter base, anomaly, and the stratified sampling I showed you earlier. These samples, as we help you fulfill the first principle of the Zen Guide, which is to understand and capture outlier examples. Principle 2 is to see the world as it truly is, because the data we see often contains a lot of errors that may have occurred during production. We need to see past those errors. Here's an example of tax data that contains several duplicates. And this we discovered as we prepared the BigQuery public data set for it. We'll talk more about this data set later. But Data Prep gives you the tools to clean data for these anomalies. Using the visual cues, you can determine if there are duplicates. And in this example, it was just a simple step to remove duplicate rows. Our third principle is focused on how we do the machine learning optimization. As you know, it's fragile. Because surfaces are not always convex and sparsity problems